Hi guys, welcome back to our TransCAD tutorial. I'm Danny. In this tutorial, we're going to learn mode split using nested logic model. I'm going to open a workspace in our tutorial folder. It's called Mode Choice Aggregate Application. Here we have a map of the zones, and also we have three tables, three matrix table. The first here is called PA. It is actually an OD matrix table. This is the output of our second step of the four-step approach, trip distribution. And here we have a table called auto SP for shortest path. It's a table of for each roadie pair the travel time for the shortest path. We actually generated something like this in both tutorial 1 and 3. If you forgot about it, you can check it out. And here we have a matrix table for buses. Across the different tabs for this matrix, we have the fare, the initial wait time, the in-vehicle travel time, and bus availability. So, for example, for fare, it tells you to go from one zone to another. What is the fare to pay? So all these three tables are in matrix format, and of course, for the zones, we also have a table behind it, which gives us the ID and the demographic information of different zones. So that's all we need for mode split. We already know how to generate the shortest path for auto, how to generate the OD matrix, but we don't know how to generate this bus matrix. And I will show how to generate this in an extra video of our tutorial 4. Please check it out. So here I'm just pretending that we have everything ready, and let's just do mode split for now. We go to planning and mode split and logic model application. Here we have two windows opened. First is a tree diagram for the logic model to be used, and the other is this dialog box. And let's load an existing model, which is called a nested logic aggregate model. We open it, and the tree diagram is automatically updated. And we also have our all the parameters and the variables set up for us. So what is this logic model here? We can see that it's of course a nested one. We have in total 3 alternatives: drive alone, carpool, and bus. And drive alone and carpool are aggregated into this upper parent level called auto. And auto and bus are at the same level. So that's our nested structure. And here we have the corresponding coefficients. In case you don't understand what the detailed information of our equation here, here I have typed it for you. So for example, the utility of bus in the logic model is calculated by the coefficient, which is here, the coefficient for time, times the in-vehicle travel time, plus the coefficient of fare times the fare, which is this second row here. So please note that these two here, they are associated with the bus. And the coefficient of time is also here in the row for drive alone or carpool. And that's why we are seeing them in here, the same coefficient, negative 0.08. So this time ij will be the shortest path travel time using auto from node I to node j. And for drive alone and carpool, we also have the coefficient of income and the coefficient of park cost. So come back to our equation. They are here, the income and the parking cost. And based on these utilities, we can go further to calculate the utility for auto as the parent level here. And then with these utilities calculated, we can go to calculate the probability for each mode. So coming back to our setup window, here the sources we provide 1, 2, 3, 4, the 4 tables as our sources in terms of the shortest travel time for each OD pair and the income or the parking cost for each zone, which are listed in our utilities tab right here. They will be the variables for the model to use. And since we loaded this well-defined model file, everything is already set up very well. And here apply, we will check the output utility values for us to view open when it's opened later. For that, we'll need to check open outputs. And here in utility scaling, we will choose none. So the utility scaling is talking about some slightly different versions of the logic model in terms of how to calculate the utility. We'll just choose the basic version, so we choose no scaling. And here the segment, we will choose home-based work trip for now. In this model file we loaded it, actually if we come here, the segment manager, it has defined 2 segments. So the segments here means the trip purpose we want to calculate. Here it defines home-based work trip and home-based non-work trip. Just for simplicity, we're going to do only a home-based work trip. And I'll talk more about these details later. So now we can just click run and see our results. So here we say yes, save the model, and overwrite it. Overwrite it. Okay, now it's finished. We click close, and we have our results. To make the windows look better, we do Windows tire horizontally. Now it looks better. So let's check our results. First, for the utility matrix, we have the utility for every OD pair for every one of the 3 modes we have. For example, from zone 10 to zone 12, the utility of drive alone is negative 1.26. Utility for carpool is negative 2.03, and for bus is negative 3.26. So just to help you understand what the model is doing and also help myself to check these numbers are correct, we can do a manual calculation of all these utility numbers. Just for this OD pair of 10 to 12, if we plug in the number for utility of bus, the equation is here, and the corresponding in-vehicle travel time, we can find it in the bus table of bus finder, in-vehicle travel time. We go to here, from zone 10 to zone 12, it's 32.21 minutes. And we'll plug it in here, and the fare will be come back to this bus table. We switch to the fare tab, and it's $1. So plug it in here, and we got negative 3 0.26 as the bus utility. In our utility table, that's the same number. And similarly for drive alone, our equation here, first is the constant, and then it's the coefficient of time times the travel time from zone 10 to 12. Back in our tables, in the auto table, we go to from zone 10 to 12, that's 4.93 minutes, which is our travel time here, plus the coefficient times income. So this income is actually a feature associated with the zones. And please note that in here, when we set up the model, it has this little sign here, which is an O and a going out arrow. So this means that this income you're talking about is the field associated with the origin zone. For example, from zone 10 to 12, this income we're talking about should be the income of zone 10. So go back to the map and we open the data view of the zones. And we sort the ID to get zone 10. And here we find its income is 23300. That's our number here. And plus the coefficient of parking cost times the parking cost. And again, this parking cost in our setup, instead of the O here, it has this icon of D. That means the parking cost is associated with the destination zone where you're going. So in our example, it will be the parking cost for zone 12, which is here. It's 0. It's free parking. So we put 0 in here. And by this, we will get our value of utility for drive alone as negative 1.26, which in our result here is the same. So similarly, you can check for carpool whether this number is right or not in here. So I think all the calculations are correct. And with the utility of both alternatives of auto, we get by this formula the utility of auto. And further, we will be able to calculate the probability of each mode. So we plug in the utility of bus and auto, we get the probability of traveling by bus as 0.07. And in our output probability matrix, from zone 10 to 12, it's switch to bus, 0.07. And for auto, it will be obviously 1 minus the probability of bus, we get it. And the probability of drive alone, that will be a conditional probability, which is equal to the probability of choosing auto times the split between drive alone and carpool. We plug in the numbers and we get the probability of drive alone as 0.633, which is the same as here. And by the way, just a little trick. When you have a matrix like this with different tabs, you can click on a cell or do right click and info so that you will have the value for this cell across different tabs all at once. So here we will see the probability of all the three alternatives. Okay, so once we have the probability of each alternative, then we simply multiply that by the total OD matrix, and we will get the splitted number of trips for each alternative, as in this applied totals of our output matrix. So this view is the number of drive alone. So we can call this the OD matrix of drive alone. And this will be OD matrix of carpool. and this for bus. All these body pairs, bus is not available. They're missing value, and we have some values for the audio pairs where the bus is available. All right, so this will be our main output for mode choice or mode split. And that's how you apply it, given you have all the files as well as a model file defined. So now let's say that you don't have this model file. I have taken a screenshot for it, the tree diagram and the coefficients and variables. Let's say that we don't have this model file and we want to build it from scratch. So now I'm going to show how to do that. So let's close all and let's redo everything all over again, except that we don't have the model file and we will build it. So we open the same workspace, mode choice aggregate. We have this table spec again, tile them, and we do planning, mode split, logic model application. So now instead of clicking load, I will move here to build it. So hopefully we can replicate everything of our loaded model just then, and hopefully we will have exactly the same numbers here. Okay, so we first need to finish the tree diagram here. So from root level, we first have an auto. So with this creepy hand, we click on root and right click on it, create child. So this first child will be auto. We click OK. And then under the auto, we have drive alone and carpool. And we right click on auto and create child. Drive alone. And here, very importantly, is this AIC, which is alternative specific constant. In our model, we are trying to replicate. It has this constant associated with this drive alone or carpool and auto in our tree diagram. So this is the constant we're talking about here. If you know something about logic model, you know that across all the alternatives, one of them, the constant is 0. So in our case, bus has the constant is 0, so that's why we don't have any constant here. The other two alternatives, they will have an alternative specific constant. So we need to type that in our new model. For drive alone, it's negative 3.2. So we type it in here and go back to auto, right click on it, create child, and we have carpool. The constant for that is negative 2.8. Yeah, and then come back to the paragraph, we just have a bus left. So we right click on root and create child, that's bus. And here the constant for bus is 0, right here. So we just leave the AIC blank here. And OK. Now we see that for carpool and drive alone, there's a letter C on it. That means they have a constant which is not equal to 0. And for bus, the constant is 0. So it doesn't have this letter C. Just to help you remember what you put in this model. And note that in our original diagram, there's a theta on the auto block. This theta is a parameter of the nested logic model, which is the 0.8 right here. So we have to put this in as well. We double click on auto, and in this theta box, we put in 0.8. And OK. So now we have finished the tree diagram. As here, looks the same. And then we should move to the dialog box here. So first of all, we can give our model a name since we're building a completely new model. We can call it a replicated model. And here on the source tab, we need to provide the tables as the sources for the logic model to read. And here the data source, we have data views and matrices. There are two types. So for the data view, it just means tables. For our case, we need the table of these zones because for some of the modes, we need things like the income or parking cost of all the zones. So that's why we need it. We click the plus sign here, and our TAZ table is already popped in there. TAZ table is just this data view behind our TAZ map layers. So here we should change the type as zonal. This means that this table is used as zones to run logic model. If you choose survey, that's when you need to estimate a logic model. So change it back to you. And you can give a name for your table. Let's call it zones. We will use this name later. And for matrices, we should add 3 matrices. The first one is the OD matrix, which is PA. That's just how they name it. And we can give it a name. Let's call it our OD matrix. And click the plus sign again. We will have our table for the cars, which is called AutoSP. And we can call it car cost. And another one is the table for buses. It's called bus pathfinder, which is right here. And here we call it bus cost. And for this primary column, we should check our OD matrix as the primary data source by double-clicking on it. Okay, and now we have provided our data tables as the sources. And coming to Utility tab, now we need to fill in the coefficients and the corresponding variables. We will try to replicate this. Okay, so we have 5 parameters other than the availability parameter already there. So we will add them, and let's use the same name as in our model here. Data for fare. Third one is data for income of driving alone. Fourth one is income carpool. The last is parking cost. Okay, and we will copy the values here. The last one is negative 0.072. Okay, now we have the values for the coefficients, but we have not told the model which data and which tab or field it should read from. For example, for the bus availability, that's this matrix defining for each OD pair if the public transportation is available or not. 0 or 1 matrix. Where to read it from? Here we have a drop down box, but we click it, there's nothing in there. And this is deliberately designed to be blank because we have 4 tables as our data source, and there will be so many different fields or tabs of them. So if the software puts in everything here for you to choose from, then it will be a huge list. So just for convenience, it doesn't have anything in there, and you should provide the items, which are the fields or the tabs of the data tables to read from, and then you will select from whatever you have chosen. So we'll do that for now. Checking this model we are going to replicate. First, we have a bus scheme.bus availability. Bus scheme is just the name that model gave to our bus table. Here we name it bus cost. And we will find bus availability, which is this. So we add it as one of our selected items. And here we also, from the bus table, we have in-vehicle travel time and fare. So we choose fare, in-vehicle travel time, and add them. So that's all for the bus table. And for the auto table, we have time. So we switch to the car cost table. That's the name we give it to it. And we choose time and add it. And back here, we have from our TAZ tables the income and parking cost fields. So we come to our zones table, that's the name we give it, and we choose the income and parking cost. All right, but don't forget about OD. For OD matrix, we have for different trip purposes the OD matrix, and here let's say we only do home-based work trip again, so we add it, and that's all we need. We will not choose any of the other. So now we have that selected, we will have things in this drop-down box. For availability, we choose from bus cost table the bus availability matrix, and for beta time for bus, we choose bus cost in vehicle travel time. For drive alone, we choose car cost the travel time, and the same for carpool. And for fare, we only have that for bus. We choose bus cost fare. And the income of drive alone, we choose income. We choose the zone's income. For carpool, that variable goes to here, the zone's income. And for parking cost, for drive alone, we go to the zone's parking cost. And the same for carpool. But remember that the parking cost is associated with the destination zone. Like here, the D we had before, so we should change that by double-clicking. Yeah, so now the logic model will read the parking cost fields from the destination zone. And if we click apply here, we need to choose the trip purpose here, but it seems that we don't have anything. That's because we haven't told this logic model tool what kind of trips we are going to do mode split. So we should go to this segment manager, and we say we want to do home-based work trip. You can have a label for it, just like a name. Call it home-based work trip, and done. So now it's there, and those variables. That means where do you find this OD matrix of home base work trip? That will be in our OD matrix tab and home base work trip. All right, and in order to read the utility output, again, we should check the output utility values, and we do open outputs after it's done, and we check none again for utility scaling. So we can save our model again, replicated model. So now we can click run, and hopefully after running we will get all the same results as here. So we do run, and I'm going to all the files. Okay, so we can do this tile horizontal trick again and go to our result of first utility again to check from zone 10 to zone 12. It says the utility of drive alone is negative 1.26, which is the same as before, and utility for carpool negative 2.03 before, and now it's the same. For probability, let's say for bus, going from zone 10 to zone 12 is 0.07, and the results we had before was the same. So it seems that we have successfully replicated this nested logic model. So I hope that by doing this replication, you can understand how to set up for different alternatives in the tree diagram, in the box, what source of data to provide, what fields to choose from. Since for everyone, for your project, you might want to define your own logic model, whether it's nested or not. So now I hope that you are already able to handle your own logic model. And that's all for our tutorial today. And please don't forget to check the other tutorial video for this, where we're going to generate the bus scheme tables, which is called the bus cost tables in our current example. We will, given a network with the bus route files, we will generate this matrix, giving us information of all the OD pairs, the bus availability, the fare, the number of transfers, and in-vehicle travel time, and things like that. So see you later. Thank you.